Have you ever wondered why an onion smells? Did you know you can use your nose just as effectively as a pH indicator? My name is Victoria Miller, and today I'm going to discuss how titration, olfaction, and the smell of an onion all come together to allow us to determine whether a solution is acidic or basic. How do we use our nose as a scientific instrument? First, we have to understand that titration is the slow addition of an acid to a base. The acid, or titrant, is added until the acid-base reaction reaches neutralization, which is when the amount of base is equal to the amount of acid, and the pH is 7, or that of water. This is indicated in labs by our color change from a pH indicator. But what makes an onion stink so bad? There are three main sulfuric compounds within the onion. The first is 1-propionyl acid. The second, propyl acid. And the third, methyl acid. What do these acids have to do with olfaction and titration? Olfaction is the sense of smelling. When these sulfur-based compounds are added to a basic solution, they donate a hydrogen atom and become anionic in a process called dissociation. So 1-propionyl acid becomes 1-propionyl. Propyl acid becomes propyl, and methyl acid becomes methyl. When these acids are in their anionic state, they're odorless. When they're in their natural undissociated forms, such as when they're in an onion, they smell. Although onions reek, they can be used productively in science. By summarizing a simple experiment with an onion, hydrochloric acid, sodium hydroxide, and water, I can illustrate how your nose can be just as effective as a pH indicator. To perform this experiment, you soak diced onion onto 3 different paper towels. Insert one of these towels into each of the containers of water, sodium hydroxide, and hydrochloric acid. Let the towel soak in each solution for about 5 minutes and remove the paper towel and waft the fumes from the paper towel to your nose. When the paper towel in the water and hydrochloric solution is wafted, the onion smell is still prevalent. This is because the sulfurous compounds are not dissociated. However, when the towel is soaked in the sodium hydroxide, there is no oniony smell coming from the towel. This is because the sulfurous compounds are dissociated, meaning the compounds lost a hydrogen. When the pH of the titration is recorded with phenolphthalein, a pH indicator, we get the following data. The chart shows a graph of the pH based on the amount of hydrochloric acid added to the sodium hydroxide. At points above a pH of 7, the anionic compounds within the onion will dominate and there will be no oniony smell. Any points below the pH of 7, the cationic, undissociated sulfuric acids dominate and there will be an oniony smell. Science is everywhere. It doesn't just have to take place in the lab or at class, it can happen in the kitchen and even in your nose. So next time you smell that horrible stench of an onion, at least you know you can blame the sulfuric acids within it. My name is Victoria Miller. Thank you for watching.